All right, here we go with 5.4 half angle formulas. Take notes and hopefully you are checking in for attendance. Okay, so there it goes again. Why doesn't it just save my settings? All right, 5.4 half angle formulas. These are also on that sheet. If you haven't had a chance to look at it, it's in the Unit 5 module on Canvas. Okay, so half angle formulas. Okay, so in this first video, there are two. So in this first one, we'll look at sine of a half angle and cosine of a half angle. Okay. All right, so sine of a half angle is going to equal plus minus. So this plus minus, it's not that there are two answers because the sine of an angle is one answer, right? We don't say, oh, sine of 30 degrees is positive and negative 1/2, right? So same thing here. The sine of some angle over here is going to be only one of these answers. We don't ever have two answers, okay? And I'll talk about how do you know when it's positive or negative in a second, okay? But this is the formula. This is on your formula sheet as well. So let's just put a little note here that you will need to determine if positive or negative. Okay? It's not both. Okay? So keep that in mind. A lot of students think that it is both when they put down their answers. All right, so let's take a look at the proof of this one. We'll take a look at this one and the one for cosine of a half angle. All right, so we are going to use the fact that cosine 2, I'll use b this time, equals 1 minus 2 sine squared b. We looked at that in the double angle formulas in the previous section. Okay, so we're going to use that fact. Okay, so all right, so we have, let's see. All right, so we have 1 minus 2 sine squared b equals cosine 2b, right? That's what it says right up there. Okay, and what I'm going to do here is I am going to solve for sine b. Okay. All right, so I'm going to subtract 1 on both sides because I want to get this sine squared b by itself and then eventually just the sine b. Okay, so I'm going to subtract 1 on both sides. And that will give me negative 2 sine squared b equals cosine 2b minus 1. Okay, and then I am going to divide both sides by negative 2. Okay. And when I do that, I get sine squared b equals the negative 2. Okay, so I'll have 2 on the bottom, right? But the negative, I won't put the negative here. I'm going to distribute the negative across the cosine 2b minus 1. So then I get positive 1 and then minus cosine 2b. Okay? All right, and then now I can take the square root of both sides. And when I do that, sine b equals plus minus the square root of 1 minus cosine 2b all over 2. Okay. All right. So there we have it. Whether we use A or B comes out to be the same, almost, right? So if you take a look here, we have this angle B, and this one is twice as much, right? Over here, is that true? Is that true here? We have an angle here, and is this twice as much? Well, in fact, it is. Okay, so right here, this angle, if you double this angle, right? Right now it's a half, right? 1/2 A. So if you double it, then you get 1A. So yes, this angle over here inside is twice as much as this one, which is what we have. This angle over here inside is twice as much as this one. Okay, so if you want, you can do this. Let A equal 2B. Then A over 2 equals B. Okay, and then you'll have the match. Okay, so here we'll replace 2B with A, and over here we'll replace B with A over 2. Okay, so this turns out to be A over 2 plus minus square root 1 minus cosine 2B is equal to A all over 2. So there we have it, the proof here. Okay. All right, we're going to take a look at also cosine of a half angle. So cosine of a half angle is going to be equal also plus minus 1 plus cosine A all over 2. So they're not quite the same. The sine of a half angle is the subtraction. Cosine of a half angle is addition. Okay. And same thing here. So this formula is on your formula sheet. And same thing here. Note you will need to determine if positive or negative. It's not both. So just like cosine of 30 degrees is not both positive and negative, square root 3 over 2. Okay, let's do the proof. All right, let's use the fact that cosine 2x equals 2 cosine squared x minus 1. Again, whether you use x's, a's, b's, okay, doesn't matter. All right, so let's start with this. 2 cosine squared x minus 1 equals cosine 2x. Okay, and now instead of solving for sine, we're going to solve for the cosine. Solve for cosine x. Now remember, you have a cosine x here, a cosine 2x over here. This is the one we're going to solve for. So we're going to add 1 to both sides. So we have cosine 2x plus 1. And then I'm going to divide both sides by 2. This one's a little more easy to follow, I think. Cosine 2x plus 1 divided by 2. And then here, we're going to go ahead and take the square root of both sides to get the cosine x by itself. So we get plus minus cosine 2x plus 1 all over 2. And again, here, it's almost exactly what we want. Let's take a look at what we're trying to get. We're trying to get a over 2 and a here. And similarly to this one up here, we see that, okay, this angle on the inside is twice as much as this. This is a half angle. This is one whole angle, right? This is half. This is one. Half, one. This is twice as much as this one, or this is half as much as that one. And if we look here, okay, this is half as much as that one, or this is twice as much as that, however you want to look at it. Okay. All right, so we could do the same thing that we did up above. We can let 2x equal a, right? And then if I divide both sides by 2, then I get x on this side and a over 2 on this side, right? So let's go ahead and replace the 2x and the x. So we're going to replace the 2x and the x with what we have here. Okay, so the x will be replaced with a over 2. And the 2x will be replaced with a. Okay, and then there we have exactly what it says up above. Plus minus square root 1 plus cosine a over 2. Okay, and the addition is commutative, so you could switch that around if you really want it to look exactly the same. Okay, so let's take a look at an example of when or how we would use this. So you might be asked to find cosine of 75 degrees, right? 75 degrees is not something we have memorized, okay? So now we have all these different formulas. We have the half angle, we have the double angle, and so what you can do to try to figure out which one you're going to use is take your 75 degrees, right? And see if this is twice as much of something that you have memorized. So remember, we memorized 30, 45, 60, right? And then the quadrantals, 0, 90, 180, 270, right? So here, let me put those down. 90, 180, 270. Okay, so here, 75 is not something that we memorized, right? However, 75, it doesn't, it's not twice any of these either, right? However, remember, we also have reference angles. Let me say, or reference angles. Okay, so the ones that have reference angles 30, 45, 60, 90, 180, 270, etc., right? So one thing you can do is, okay, well, I have 75. If I take half, right? So 75 divided by 2, right? And we're going to get something that we never memorized, right? So we get 37.5, I think that is. We didn't memorize that, right? If we do double, right? 75 degrees times 2, right? Then we get 150 degrees. Okay, so this is the one we do know, right? Because that one has reference angle 30. Okay, so you can try doing halves and doubles and see if you get something that you have memorized or something that has a reference angle of something you memorized. This one does. Okay, so I'm going to go with that. 75 degrees is going to be 150 degrees over 2. Okay, right? 75 is 150 divided by 2. Okay, so then here, cosine 75 is going to be cosine of 150 over 2. And now, right here, this is my half angle, right? This is when I use my half angle formula. When you have something written as something over 2, right? Cosine of something over 2. Okay, so over here, okay, so 150. So cosine 75. Let's figure out, are we going to do positive or are we going to do negative, right? And we're going to be using this formula right over here. Cosine, cosine of A, okay? So that's going to be 150, okay, plus 1 all over 2. But we have to determine if we're going to take the positive or the negative. Well, okay, so this is going to be the answer to this expression right here. Cosine of 75 degrees. Where is cosine? Where is 75 degrees? Okay, 75 degrees is somewhere in quadrant 1. Okay, so it's in quadrant 1, and we know that the cosine will be positive. They're all positive, right? So here, I'm not going to use the negative. I'm going to use positive. Okay, all right, so, and I don't have to keep the positive there. It's understood. All right, so 150 degrees is over here. Okay, 150 degrees. And cosine here is negative. So we're going to get, when we evaluate this part, we're going to get negative square root 3 over 2 plus 1. Make this a little taller. Okay, all over 2. Okay. And then over here, I'm going to multiply everything by 2 to get rid of this little fraction that's within this bigger fraction. So multiply this by 2, this by 2, and this by 2. Okay. And that will give me negative square root 3 plus 2 and plus 4. Okay. Okay. And if you want to split this up, here I'm going to write it like this instead. Less symbols. So if you want to split it up like that and then simplify the square root 4, that would be good. So we get this answer here. Okay. Now you might be looking at this problem and you might be thinking, well, cosine 75. Here, I'll write it down over here. Cosine 75 degrees. Didn't we do that before? And didn't we rewrite 75 as 30 degrees plus 45 degrees? And then we used the sum and difference formulas? Yes, we did. Okay. Could you do that again? Yes. On the test, can you do that? Yes. Okay. So whichever formula you're able to use, you can go ahead and use it. Okay. It doesn't matter to me. Like this problem, you could have used the sum formula for cosine, or you could have used the half angle. Okay, either one is fine. All right, so that's it for part 1. Part 2, we're going to take a look at, again, drawing triangles in a quadrant to figure out some of these problems. Okay, all right, so text me if you have any questions or email me.